So yeah, let's go ahead and get the technical update, and then we'll move on to other things.
Okay, so the status of the networks is the same as last week. There are different configurations they're running in the development environment for the performance tests and all that, but that doesn't impact any of the things on the test net and or the main net. The main focus, of course, is block merge, and Nutzipper made significant progress on the leaderless block merge, and we expect to have a running R node based on the leaderless block merge in the development environment sometime next week. So he's resolving the last few issues and doing the integration with the existing code base to be able to get to that state of being able to have a running node. The piece that he has been mostly working on in the last several days was merging state based on a fringe or boundary of previously last finalized states. And this, again, I spoke to this, I believe, either last week or the week before. But just to remind people, this is necessary because when you have a 67% stakes situation in a leaderless merge, block merge, there can be different states that have been finalized as last finalized state in the past. So when you're doing a merge now, you have to be able to take into consideration all of those states and the and their rejections and any conflicts, along with the new state that you're trying to merge into that. That's the work that he's been working on. So even though we're still calling this block merge, really it is now a state merge is what we're talking about. And Nutzipper will do an explanation and demo in more detail today. On this piece, once this, now in doing this leaderless block merge, there was a lot of refactoring we had to do in Casper, as well as in the tests for Casper, which is the refactoring of the tests is yet to be done. Because Casper, the way it was written back 2017 to 2019 timeframe, was written with more of a single parent, bunch of single parent assumptions, and certainly all the tests were written with that assumption. And because the thinking at the time was that initially it would when we go to the mainnet, it would be with a single parent version was the reason why they were focusing on it that way. The other thing that was being done in the tests is to just run the whole node from Genesis in each test, which of course is very time consuming and also more importantly, difficult to maintain because anytime we change the code for the node anywhere, we'll have to change this test that's trying to run through the whole node stuff. So this is what we need to refactor, and but we'll be taking that on next week once we have the leaderless block merge and our node with running with the leaderless block merge. So that's where we are on that stream of things. The other stream that Tomislav has been working on was to directly merge rev balances. This, if you recall, started with a limitation on the per validator walls causing too many conflicts, which then we said we maybe need to think about per deploy walls. And from there, it evolved into really, why don't we just directly merge the rev balances so that the conflicts are reduced as well as the performance is improved. So that stream is also going to be available. It'll be ready for testing next week. Tomislav is finishing up the pieces. There was an issue that I listed in the last report that has the details, but since some people are complaining about too much repetition, maybe I should link back to that issue here, but I took that out. But anyways, so this work is also getting ready for testing next week. And when we have that piece, for one thing, it should enable leaderful block merge right away. But really what we're moving towards now is to say, well, since leaderless is ready, that's going to be our main focus to get the whole thing done. So that's where we are with those. Work is continuing on the performance tests. Gurinder did some testing last time, and basically it appears as though the linear scaling was tapering off after 25 or so nodes, and we are investigating why that is. We don't have, what I put here is really just the suspicions, and we are, it may be because there's too much accumulated state, but it could also be just because of how we are running the test environment, because we're running all scenarios on the same machine at this point in time. Because that's both time efficient and cost efficient without having to do a full simulated network. So maybe that is a part of that, or configuration could be a part of that as to how we're doing heap configuration and other things. So there are a few things that need to be looked into, and this is what Will is doing. And we believe at this time that this is fully resolvable. Meaning we don't see any logical reason why it should be slowing down. So once we have a resolution on this, we'll have some data, performance data that we'll be reporting. The other thing after all of this is we're going to take some focus or put some focus into faster debugging or debugging tools, improved debugging tools, so that the team can get through development and release cycles a little bit faster with more efficiency. So that's something we're going to look at. Dennis is on vacation this week, but he's working as time permits on the Radix tree implementation and moving that forward. So that's where we are. Those are my main updates for today. And before I hand it over to Nutzipper for a full explanation on what we're doing in this merging of the states. Yeah, one thing also I wanted to point out in merging of the states, the way we're doing it now, it eliminates the problem from lazy validators. Because previously we were thinking about, well, if a validator doesn't do something, how do we track it? At what point do we decide that it's dead? And is there any slashing behavior that we need to think about? Because it's not fair that one validator does nothing but gets the rewards, whereas others have to do work. So there's a whole bunch of issues around lazy validator that we expect that this would resolve, and maybe Nutzipper can speak to that in a little bit more detail. So those, that's my update. Are there any questions, anything that people, any comments, questions that people have before I turn it over to Nutzipper? All right, over to you, Nutzipper. I'm going to stop sharing.
Sure, thanks, Rao. Hey, everyone. Let me share. Can you see my screen?
Yes.
Okay, great. So I want to talk about what Rao mentioned, our update on the Casper side, which actually emphasizes everything good that is in RChain, and I'm going to go through that in a minute. So basically, let's start that with the decentralized network. You're supposed to have the value of a network is an agreement of independent parties on something. And consensus protocols are about agreeing on something. if you have a leaderless network, you have consensus decisions, not decisions by everyone. This means that if we have a DAG, 2/3 of the stake are built on top of many messages, and effectively this is what was not accounted in current previous version of the Casper. This means that there are multiple messages that that have 2/3 of the stake above, and all of them are finalized. So how to deal with that? Good thing that if you have a composable state, like if your state machine is row calculus based, you can do that. And thanks for Greg for advice to annotate DAG with the row terms. I won't go into that, but if you want me, I found this like extremely useful, and it clears lots of stuff. But what Rao wanted me to talk about is that particular finalized fringe. You can see that we have lots of stuff here, and it has very long circumstances, lots of circumstances, and I think that this new thing might help us clear many things in different ways. But with particular version of particular problem of lazy validators, this new thing allows us to reason about each message in terms of the message scope. So each message is in fact the scope, and the scope is bounded from the bottom by the boundary, message scope boundary, and at the top is the tip, which are latest messages on top of which new message has been created. It's a dashed one here. So latest messages defines finalization. This is how Safety Oracle and Casper works. If message propagate its stake on top of some another, if 2/3 propagated stake on some another, for example, LM1, 2, 3 propagated its stake onto F2, F2 is finalized because 3 or 5 agreed. So we had to change slightly an agreement rule. Now it's not just that message is built on top of another message, it's about agreeing of states. If we talk about row states, it's basically 2 tuple spaces. If on merge they create a COM event, they're conflicting. And we can decide and we can find out if this happen actually. Having our current merging logic, I won't go into that. But what's interesting is that now we don't have a single finalized state. We don't have a single finalized block. It's more valid to say. We don't have single finalized block. And this is interesting thing because this actually tells us that it can scale because we can have multiple partial finalized states and multiple partial finalized states in multiple finalized blocks, which means that yeah, I was talking with Tomislav and we're thinking, okay, so anybody else can have multiple finalized blocks or not, like finalized blocks which are not in ancestor-parent relation. So this is an interesting question, and it might be like a criteria for defining can you do merging or not in your blockchain, in your decentralized database. And this shows that we can, because we have this fringe. You can see this greens one is the finalized fringe. To be able to create a new block, you need to merge this scope, and that's it. But the fact that this finalized fringe is defined, you're the finalized state of the network, which means that if someone is old, very lazy one, and it will try to use justifications below this fringe, this means that this node is not capable of keeping up with the network. And this quite good way to determine and just cut off such validators. If someone will create message with very old justifications, this message, which is about to be created, will see that there are some old justifications and I need to just ignore this block, which means on rejection, we will, on merging, we will reject everything that this proposer is trying to put in the network. And this might be actually the signal for the proposer, because we have also this problem. If you're starting a node from the pruned state, you don't know when actually you're going to be proposing, because you have this interval of catching up. So you need to catch up with the most recent state of the network, and then you have to know when exactly you're catched up enough and you are able to propose changes to the network. And this fringe is perfect criteria for that. Once you see that you can propose a block and it won't be ignored, this means that you catched up. I hope this makes sense. There are lots of stuff, and I hope that I could explain it in a convenient way.
Well, thank you, Nutzipper, for giving us the presentation. So just a few clarifying points for maybe people who don't have all the context that we do. In the diagram, the way it's represented, the top dashed circle represents a block, which is also a message that a validator is attempting to create. And in order to create that, a certain number of things has to happen. So in particular, the block has to have justifications, which are previous blocks. And that's what all of those arrows coming out of the dashed circle represent. And what makes the fringe be the finalized fringe is that each one of the red ones along the border, that is the sort of red border, each one of those has more than 67% of the stake. And so that's what makes it a part of the finalized state. And the reason you're interested in a full border that spans across all validators is that until you have that, you don't have a complete view of the state. So each circle, which is a block, represents a partial view of the state. When you have a border that spans completely from one end of the diagram to the other, that represents a full view of the state. And essentially what's happening is, as things are finalized, you get these little paths across the diagram, little what we were calling fringes, that will keep advancing as time goes on. And when those fringes advance, you can see that as a kind of relativistic clock, right? So each time you construct a new fringe that's moving higher up the chain towards in the direction of the tips, that represents an advancement of state evolution, which then corresponds to a notion of time. Hopefully that gives people enough intuitive scaffolding in order to begin to make sense of the diagram. Any other questions for Nutzipper or Rao or myself?
So concerning the diagram here,
Mm-hmm.
I realize we're concerned more with completeness here than consistency at the beginning, and that's the reason for this fringe. I am curious if you could explain.
No, it will. The fringe will give you consistency as well as completeness, and the
Okay.
way the consistency is manifested is when you do the merge. So Nutzipper is essentially talking about creating consistency at the merge points.
Okay. So I'm curious about the red circle to the right of F2 and below F3.
This one.
Yes.
And it seems like that disappears even though it's received information.
No, it's in F3. It's everything that is below the fridge is seen because every message should have self-justification. It won't disappear because F3 has it.
Yeah, F3. Yeah, you don't have to go below F3 because F3 already has enough stake, and F3 sees what that block sees.
So if this is finalized, then everything which is below is finalized, which means that we have a procedure to merge all these changes into one state.
Good question. Thanks, Bill. Any other questions?
I was wondering if it's productive for either one of you to explain the decorating with Rolang terms as a way of thinking about these transitions. I don't know if that might help some of the developers, but
if you want to scroll up, Nutzipper, I can go through this very quickly. So the main advantage of Rolang and the process algebras in general, and in fact it's not just the process algebras, it goes for all of the calculi style presentations of computation. So this includes lambda calculus and the pi calculus and the row calculus and the ambient calculus and the blue calculus and yada yada yada. Right, so all of those styles of reasoning about computation have one thing that is significant over other presentations, which is that what you see is what you get. When you're looking at a Rolang expression, you don't have to, which you can think of as a program, as a computation, you don't have to imagine that there's other context that is impacting what you see. By comparison, if you look at a Java program, if you don't know the state of the heap, or you don't know the state of active threads, or you don't know the state of the stack, how that code, which is right in front of your eyes, executes will change. So there's hidden context that is not present in the code. If you have a model of computation that is like that, then things get very difficult, both for programmers and for proving correctness. Now, the reason that's important in these diagrams is when you have that property, then you get this additional property that program and state are the same thing. So you can use programs to represent state. And essentially, that's how you, and you can also use programs to represent state transitions. So all of the decoration of the diagrams here have to do with how we move from a state, which is recorded in a tuple space, to the next version of the tuple space. So therefore, when you're looking at the circles and how they represent state, you can decorate them with row calculus terms. And the nice thing about that is that we know that the promise that the tuple space gives you as a row calculus or Rolang term is that there are no COM events in it. That's the essentially one of the consistency constraints of the tuple space, is that there's no reduction that can happen. It's a quiescent program. So if you look, for example, at the white circle just above S1 prime, that represents an output on A and an output on B. And notice that you can't, A can't talk to B and B can't talk to A. And even if they could, so even though they're in parallel, that tuple space is stable. There's no communication that could possibly happen. Now, the way we get to that state is if you assume that S1 prime has nothing in the tuple space, right? So it's an empty tuple space for various reasons. Then we can label the transition, which is a couple of produces, right? So a couple of storing data on A and storing data on B. That will be what the difference between S1 prime and that bubble. If we don't make that assumption, if there's additional state, then you can see if there's additional state associated with S1 prime, then you can see that the bang A pipe bang B represents the state delta between S1 prime and where the arrow is currently sitting. So you can see that the arrows are representing the changes, the deltas, and then we can represent the states again in terms of either the tuple space or the deltas to the tuple space. And you can also note that if you are attempting to merge, if you merge and you create a COM event, so if you look just to the right of the AB, right, there's an input on A and an output on A. And so merging that creates COM events is not going to work, right? That's the rule on merging, is we're not going to allow that. All COM events have to happen on the arrow transitions, not on the merge transitions. Does that make sense?
For me, yes.
All right. Well, maybe we've given people something to chew on. If you want more explanation or more information about it, feel free to watch the video later. Also contact myself or the dev team. We can provide you with additional context. But perhaps for those developers or those people out in the community who regularly use GitHub, I want to use that as a yardstick for how fast we should expect this ultimately to get to be, even though right now it's not currently that fast. I remember the first time I used Git, I was working with an extremely large code base, and I wanted to do an update with Git, and I issued a particular command related to the update. And when it completed, and I thought it was that what had been completed was just the preparation to go and do the real command. When in fact, the whole thing was completed. The whole update was completed. I was shocked by how speedy Git is. Now, if you think about it, Git is doing an even more sophisticated merge than we are, because the kinds of things that are being merged in Git don't have the clear notion of what conflict is, right? So in a lot of conflict situations, Git has to turn the conflicts over to the developer and say, hey, I can't figure this out. You're going to have to do that. Because we have such clear rules about what can be merged and what can't be merged and what must be rejected, we don't have anywhere near the kind of complexity that Git has. And if you look at how fast Git is with respect to merging, we should be able to surpass those speeds over time. I'm not saying that our initial implementations will have that property, but there is nothing in principle that prevents the merge from being at least as fast, if not much faster, than Git merging. So if you need a yardstick by which to measure this, that would be one way to think about it. Does that make sense to folks?
The yardstick makes sense.
Good. That's all I wanted you to get, was think about, merging and merging pull requests using Git, And this is effectively that, only on steroids. It's better because we know so much more about the kinds of things we're merging. When you're merging just ordinary text, what counts as a conflict is going to be much bigger than what counts as a conflict here. So we have a much richer semantic universe in which to calculate the merge, and so it can go much more smoothly. All right, thanks to everyone for this. I really appreciate your presentation, Anton, and thanks for the questions, Bill. But maybe it's time to move on. Any other questions on the tech update before we move on? Okay, great. Let's go ahead and get all of the housekeeping out of the way before talking about some board discussion and other kinds of things. So Daryl, are you ready for the week in review?
Yes, I am.
Go ahead.
Okay, so just before I start the week in review, I have never spoken to you in person, Nutzipper, and I would just like to kind of announce this to the world. 3 words that I've been wanting to say to you for a while, and that is, you are awesome.
Thank you very much. I'm very pleased.
Well, thank you. Thank you for all your contributions. Seriously. Okay, so here's the week in review for September 2nd to September 8th. On Thursday in the governance committee, this discussion mainly revolved around being prepared with monetary policy for external validators as they come online in the coming months. Also on Thursday in Jim's work study, actually on Thursday and Tuesday in Jim Works studies, they continued working on chat, the ballot, and Jim did a Rolang training session. On Friday in the Climate and Coordination RCast, Sven from Team Human joined us and discussed the Thousand Nations Democracy Experiment. We also discussed Hurricane Ida, unprecedented flooding around the world this year, and the extinction of tree species. On Monday in the Casper Stand-Up, this week's Casper Stand-Up explored the scope of applicability of the row calculus to the physical sciences. Specifically, we looked at Smith and Morowitz's proposals regarding the origin of life on Earth, noting that their proposals regarding the development of metabolic pathways from geochemistry are all amenable to model in stochastic versions of the row calculus. We moved on to consider Mark Solom's proposal for the origin of consciousness. In this context, observing the similarity of the 2 theories. In particular, both represent the origin of living and then conscious structure, respectively, as arising from systems far from the equilibrium, finding a way to channel the surfeit of energy flowing into the geosphere from the sun. And like the Smith and Morowitz proposals, Solom's proposals are readily modeled in row calculus. This goes a long way towards the hypothesis Greg has been arguing that we are at the end of the Newtonian hegemony, in the sense that Newton's calculus will be replaced by different formalisms for modeling dynamical physical systems. The row calculus is a candidate for such an alternative. Wow. So yeah, that would probably be a really interesting one to tune in on. I'm going to be editing it over the next day or two and hopefully have it uploaded soon. Sounded fascinating. Let's see, on Tuesday in the communications working group, we discussed strategies around the NFT sale and onboarding NFT influencers as derivative collaborators. And there was no active member hangout today, which is odd. And I'm a little concerned about whether Jim's okay, because it's never happened before in the history of my memory. And let's see, I also have a recap from Shutzi from the Chinese community. This week, there are some new articles about comparing RChain with Solana and discussion around concurrency. There is a growing interest from the Chinese community members around what's happening with RChain's NFT plans. And in addition, Shutzi has been working on translating an important YouTube video from August 2020 involving deconstructing RChain with Greg. That is what I have for the community update.
Just a note, in addition to Daryl's presentation, thank you, Daryl. Jim Weiscarver is unavailable today because he's on an airplane coming to my home for my wedding.
Oh, awesome. I love that reason.
Yeah. Well,
Good.
congratulations, Bill.
Yeah, mazel tov.
Yeah.
Awesome.
Any other questions for Daryl? Thank you, Daryl. I appreciate it. Okay, moving on then. So the board had its regular meeting yesterday. It was a productive meeting, many topics to cover. In terms of votes, so I think we pushed the approval of previous minutes to the special board meeting coming up this coming Tuesday, because there was a lot of vigorous and active discussion around how the board wants to approach the upcoming NFT sale. So I won't mention the details here and leave that to the Friday call. But I do want to say that there was it was a very productive session, and I think in general the right sort of delegation has been achieved. So I mean, at the end of the day, everybody stays in the loop, right? The principle of RChain is transparency. So it's not like we're going to keep people out. It's just we don't want people to have to. We don't want necessarily decisions that can be done at a lower level to have to bubble up all the way to the board every single time. So that's what I'll say on that matter. Any other topics I need to cover from the board? Ian, Rao, Daryl, Steve?
No, I think you've got it.
Yeah. Perhaps just a reminder about any IOBs that people want to do for the board to consider.
Yep. Yeah.
Deadline for that.
Yep. Thank you. So I know that there's been some unrest and discord around the board composition. The board itself has been thinking about putting together an IOB with respect to the whole board structure and composition. If others want to take their worries and concerns in a positive direction by making proposals that the community can consider, please do so. Put together an IOB and get it in time. What is it? Is that the 24th of September? Is that the date we've set?
That is
Yes, it is.
Okay.
Very good. So on the 24th of September, we will close out consideration of any additional IOBs. So if you want to have your voice heard, if you've got a constructive proposal for the cooperative, please put it in writing and submit it as an IOB. I think that covers it with respect to board stuff. Any other questions, comments, burning issues from the community that need to be addressed here? All right. I really appreciate your engagement, your involvement. Looking forward to seeing the implementation come together of this refactoring of Casper. I'm very excited about it. And so please, everyone, stay safe, stay cool, and see you on the other side.